Modern metal forming combines precision and power, using advanced bending machines to shape steel and iron with unmatched efficiency and accuracy. HY100 is a high-strength alloy steel designed for applications requiring superior toughness and resistance to deformation under high stress. With a yield strength of 690 N per square millimeter, it is particularly suitable for manufacturing pressure vessels, submarine hulls, and heavy-duty machine components. The material thickness used in this process is 100 millimeters, and the plate length reaches 3,100 millimeters. The top roll diameter measures 600 millimeters, while the side rolls have diameters of 530 millimeters. The machine performs pre-bending at 65 millimeters and rolling operations on thinner plates up to 2 millimeters. HY100's mechanical properties ensure accurate forming with minimal springback. The 4-roll hydraulic plate bending machine is an advanced piece of industrial equipment specifically designed for forming high-strength materials, such as HY100 alloy steel. With a yield strength of 690 N per square millimeter, this material demands exceptional power, precision, and rigidity from the bending system. The machine in this configuration handles plates 3,000 millimeters in length and up to 100 millimeters thick, requiring significant hydraulic force to achieve a bending diameter of 1,800 millimeters. This 4-roll design includes 1 upper roll, 1 lower roll, and 2 side rolls. The top roll acts as the main bending roll, while the lower roll functions as a feeding and clamping roll. The 2 side rolls provide the lateral force required to form the material into a precise curvature. The use of a swing system in this model increases bending efficiency by allowing the side rolls to move along a controlled arc path rather than a straight vertical motion. This creates a natural bending trajectory that follows the plate's deformation line, reducing stress concentration and improving the smoothness of the curve. The bending operation begins with the pre-bending phase, a crucial step that eliminates flat ends and ensures a continuous cylindrical shape. In this stage, the steel plate is inserted between the top and bottom rolls. Hydraulic clamping pressure secures the material, and one side roll moves upward to start the bending of one edge. By carefully adjusting the top roll's downward force and the side roll's position, the plate edge is bent to match the desired curvature radius. This operation is repeated on both ends of the plate to achieve complete pre-bending before full rolling. Once the pre-bending is completed, the operator proceeds with the rolling phase. The top roll exerts constant downward pressure, and the bottom roll rotates to feed the plate forward. The side rolls, controlled by independent hydraulic cylinders, move incrementally to guide the material's curvature. Throughout the process, hydraulic sensors continuously monitor the roll positions, pressure, and torque. The data is processed in real time by a programmable logic controller, ensuring the bending diameter remains precisely 1,800 millimeters. The hydraulic system of the 4-roll press is designed for both power and precision. Each roll is driven by a dedicated hydraulic motor, enabling synchronized rotation and eliminating slippage. Central and side hydraulic supports stabilize the heavy steel plate during bending. These supports are especially important when working with 100 mm thick plates, preventing deflection and maintaining perfect alignment throughout the process. The swing system gives the machine a unique advantage over traditional three-roll benders. In conventional machines, side rolls move vertically, creating uneven stress and limited control near the edges. In contrast, the swing movement in this four-roll design allows smoother load distribution, greater mechanical leverage, and a reduction in required force. During the bending process, the top roll, with a diameter of 600 millimeters, serves as the forming axis, pressing the material into shape while rotating. The side rolls, each 530 millimeters in diameter, move upward and inward to define the bending diameter. As the plate advances between the rolls, it gradually transforms from a flat sheet into a perfectly curved cylinder with a diameter of 1,800 millimeters. The bottom roll assists by clamping and propelling the plate forward, ensuring even pressure distribution along its entire length. To guarantee surface quality, all working rolls are induction hardened and ground to a fine surface finish. This prevents surface marks or damage on the material, especially important when working with high-value alloy steels. Lubrication systems continuously supply oil to the roll bearings and hydraulic components, reducing friction and extending machine life. Safety and control are integral to the system's design. The machine is equipped with an electronic control panel featuring digital readouts for roll positions, pressure, and bending angle. The operator can preset the desired diameter and allow the PLC to automatically adjust roll movements and pressure levels. Emergency stop systems and safety barriers ensure safe operation even during high-pressure forming. After the rolling operation, the machine performs an automatic alignment and calibration cycle, checking the roundness and diameter uniformity of the finished cylinder. The hydraulic side supports then lower, and the rolled piece is removed either manually or with the assistance of lifting devices. The four-roll hydraulic bending machine is also widely used for forming Street 52 steel, a medium-strength structural steel with a yield limit of 360 N per square millimeter. This material is commonly used for pressure vessels, machine frames, and structural components that require high weldability and toughness. The bending process for ST52 steel involves a plate width of 6,000 millimeters, with a machine length of 9,200 millimeters, width of 2,200 millimeters, and height of 2,310 millimeters. The bottom roll diameter is 440 millimeters, while the side rolls measure 360 millimeters, and the top roll is 470 millimeters. These dimensions allow the machine to handle wide and thick sheets while maintaining stability and precision. The operation begins by inserting the plate into the feeding area, where hydraulic clamping holds it firmly between the top and bottom rolls. The side rolls are then positioned to apply lateral force and initiate the pre-bending. As the rolls rotate, the plate gradually takes shape, forming a smooth curvature without wrinkles or edge flattening. The 4-roll configuration enables the machine to complete the process in one pass, significantly reducing production time. Because Street 52 steel has lower yield strength than HY100, less bending pressure is required. However, precise control is still necessary to prevent overbending. The hydraulic system compensates dynamically for plate thickness variations and ensures symmetrical roll movement. The result is a perfectly rolled cylindrical or conical structure, ready for welding and assembly. This efficiency makes the 4-roll hydraulic press the preferred choice for workshops that handle both heavy-duty and standard-grade steels. For very long plates, such as those with a working length of 500 millimeters, the 4-roll hydraulic press must deliver exceptional structural rigidity and balanced pressure distribution. In this configuration, the machine is designed to pre-bend plates up to 10 millimeters thick and perform full bending on plates up to 12 millimeters. The rolls, each with a diameter of 460 millimeters, are induction hardened to resist wear and guarantee surface durability. During operation, the induction-hardened rolls maintain consistent contact pressure across the plate's entire width, preventing slippage and surface marking. The pre-bending process is critical for achieving tight cylinder ends without flat zones, ensuring seamless joining when the edges are welded together. Because of the extended working length, synchronized hydraulic cylinders control each roll's position with high precision. This prevents deflection and maintains uniform curvature over long sections. The result is a perfectly rolled structure with consistent diameter and smooth finish, suitable for large storage tanks, silos, or wind tower sections. The machine's advanced control interface allows the operator to manage pre-bending, rolling speed, and curvature radius effortlessly, providing a reliable and efficient bending solution for oversized steel plates. E-Case. The Voith Hydropower Spiral Case is a large welded steel structure made from Q345B material, measuring 8,300 x 8,964 x 2,800 millimeters and weighing 21,924 kilograms. It is a critical component in directing water flow uniformly around the turbine runner to ensure optimal efficiency and performance. The manufacturing process involves several key operations, including rough and finish machining, structural welding, assembly, and stress relief annealing. These steps guarantee high-dimensional accuracy, strong weld integrity, and long-term reliability under high-pressure water conditions in hydroelectric power plants. Repcon hot spinning technology represents an advanced forming process that combines precision, efficiency, and material integrity. The principle of hot spinning is based on rotating a metal workpiece on a lathe while applying intense heat from a torch directly onto the surface. As the metal reaches its plastic deformation temperature, it becomes malleable, allowing the shaping tool on the lathe to press against the heated area. This controlled pressure gradually forces the metal to distort and follow the required contour as it spins. Unlike conventional machining or forging methods, hot spinning requires relatively little force, as the heat drastically reduces resistance during forming. This enables the production of parts with seamless shoulders, reduced thickness variations, and improved structural integrity. The process is particularly effective for shaping cylindrical or conical components and for necking down sections to smaller diameters without introducing welds or weak joints. One of the key advantages of Repcon technology is its ability to deliver high repeatability and dimensional accuracy while maintaining the mechanical properties of the base material. It also allows the efficient production of complex geometries with minimal waste. Consequently, Repcon hot spinning is widely applied in industries such as aerospace, defense, and energy, where precision, strength, and reliability are essential. Through this innovation, Repcon has established itself as a leader in advanced metal forming solutions. The forging process at Imbach and CIEAG begins with the careful selection of raw materials from a vast inventory of more than 150 metal grades. These include stainless steels, heat-resistant and acid-resistant steels, nickel, titanium, copper alloys, and special materials such as pure iron and molybdenum. Each batch is inspected to ensure consistent quality before heating and forming. The core of Imbach's production lies in hot deformation, where metals are heated to high temperatures to increase ductility and then shaped under massive pressure. In the open die forging process, the material is placed between flat or contoured dies and hammered or pressed until the desired geometry is achieved. This method is ideal for producing high-strength components in small batches, from 2 kilograms up to 4,000 kilograms, with a fiber orientation aligned to stress directions, providing superior mechanical properties. A programmable 3,000-ton press ensures high efficiency and reproducibility during this stage. For circular or seamless parts, CNC rolled rings are produced without any welding. These rings feature a homogeneous, fine-grained structure, free of internal defects and perfectly sealed against gases and liquids. Their smooth and precise surfaces require minimal machining, making them ideal for CNC operations and achieving accurate final dimensions with little material waste. Imbach specializes particularly in seamless aluminum rolled rings weighing from 2 to 2,000 kilograms. In the case of larger production runs, closed-die hot forging is used. The metal is deformed inside a die cavity that shapes it into complex forms with tight tolerances. This process minimizes excess material and can even produce near-net shape parts, reducing machining time. Die design and metal flow are optimized using advanced simulation software, while prototype dies can be 3D printed to validate the geometry before mass production. After forging, precision machining is carried out using modern CNC equipment. This step includes pre-machining, drilling, turning, and milling to achieve exact dimensions and surface finish. Imbach also provides full assembly and inspection services, ensuring that every finished component meets functional and dimensional standards. Throughout the entire production chain, From material preparation to final assembly, strict quality controls are applied. Each component is inspected for dimensional accuracy, structural integrity, and compliance with specifications before being safely packaged and delivered worldwide. Through a combination of advanced forging technology, modern machining systems, and expert craftsmanship, Imbach ensures the production of durable, high-performance metal components that meet the most demanding industrial applications. The Repcon rotary hot swaging machine performs metal forming through a controlled, high-temperature process. First, the workpiece is heated to enhance malleability, then fed into a rotating swagging head equipped with multiple dies. As the spindle spins rapidly, the dies repeatedly hammer the heated metal, gradually shaping it into the desired form, reducing diameter or creating tapers. This precise, automated control ensures uniformity, accuracy, and high-quality results for critical industrial applications. The production of stainless steel spheres begins with selecting high-quality stainless steel sheets. These sheets are cut into precise circular blanks, which are then pressed into hemispheres using hydraulic molding machines. Two hemispheres are welded together by advanced automatic welding equipment to form a perfect sphere. After welding, the seams are carefully ground and smoothed to ensure a seamless appearance. The spheres then undergo semi-automatic polishing, where multiple polishing stages create a bright, mirror-like surface. Finally, each sphere is inspected for roundness, surface quality, and finish before packaging. With diameters ranging from 19 millimeters to 5,000 millimeters, these stainless steel balls are produced with strict quality control to meet diverse decorative and architectural applications. The Tubi plate rolling machine provides advanced roll forming solutions with exceptional precision and efficiency. Equipped with two burning tables, both hot and cold rolls, and a state-of-the-art stress-relieving furnace, it ensures superior quality and dimensional accuracy. This fully integrated system reduces lead times, minimizes production costs, and speeds up delivery, offering a complete and cost-effective plate rolling process from start to finish. Tech Tubi Record is a leading manufacturer specializing in the production of welded and seamless butt weld fittings in all sizes up to 120 inches, covering every wall thickness and material grade. The company's facilities are equipped to handle a complete range of manufacturing operations, from forming and welding to machining and heat treatment, ensuring precise tolerances and superior metallurgical integrity. Its advanced production capabilities allow Tech Tubi Record to supply fittings suitable for the most demanding industrial applications, including oil and gas, petrochemical, and power generation sectors. The plant's T-cold forming production line utilizes heavy-duty presses and precision dies to produce tees with exceptional accuracy and mechanical properties. Pipes are cut, heated, and expanded using specialized mandrels before being shaped under controlled pressure to ensure consistent wall thickness and flawless internal surfaces. The process guarantees dimensional precision and repeatability, even for thick-walled or large-diameter fittings. The company also manufactures mission-critical fittings for nuclear power plants, meeting the most stringent safety and quality standards required for such environments. A dedicated laboratory for testing and inspection supports the entire production process, conducting mechanical, chemical, and non-destructive tests to certify product compliance. Encore. At the Tech Tubi Record plant of Castel, covering a total area of 251,000 square meters, the company produces seamless hot-forged Mandrel elbows up to 56 inches in all sizes and materials. This facility integrates both hot forming and precision machining departments to deliver elbows of exceptional strength and uniformity. The plant features an advanced gas mandrel and bending machine, designed for high-accuracy forming of pipes and elbows under controlled heating conditions. This system allows the smooth and continuous production of bends with minimal material deformation. Large-dimension induction mandrel and bending machine extends production capacity to massive pipe sections. Measuring 66.5 meters in length and 7 meters in width, it exerts a maximum working force of 800 tons and provides heating capability up to 850 degrees Celsius, processing up to 11.5 tons of material per hour. This powerful equipment enables the efficient forming of large radius bends for heavy-duty industrial pipelines. The Tech Tubi Record plant of Calendasco, Piacenza, Italy, spans a total area of 800 square meters. 800 covered and focuses on the production of cold-formed elbows in stainless steel and special alloys up to 16 inches. Using precision forming dies and hydraulic presses, this unit ensures excellent surface finish and dimensional accuracy for high-performance piping systems. The installation of the 140/20 ton crane for De Ruyter Stahlkabel BV was a carefully coordinated process involving precision engineering and teamwork to ensure both safety and performance. The operation began with the preparation of the foundation, where concrete bases and steel anchor plates were thoroughly checked for alignment and level accuracy. This step was crucial to provide stable support for the crane's massive load capacity. Next, the main steel structures, including the crane support columns and runway beams, were delivered and positioned using mobile cranes. Each section was carefully lifted, aligned, and bolted into place, ensuring precise vertical and horizontal alignment. Once the framework was assembled, technicians installed the end carriages and the main girders of the overhead crane. These massive components required synchronized lifting to prevent deformation and to achieve a perfect fit. After the mechanical structure was in place, the crane's hoisting system was mounted. The 140-ton main hoist and the 20-ton auxiliary hoist were installed along with their wire ropes, hooks, and safety latches. The electrical system followed, with power lines, control panels, and sensors connected according to the manufacturer's specifications. Engineers tested the electrical circuits, limit switches, and overload protection systems to ensure reliable operation. Subsequently, calibration and functional testing were performed. The crane underwent trial lifting with gradually increasing loads to verify the accuracy of motion, hoisting speed, and brake response. Adjustments were made to balance the trolleys and fine-tune the control synchronization. Finally, after safety inspections and certifications, the crane was officially commissioned. The fully installed 140/20th-ton crane now operates smoothly across the production hall, enabling die Ruder Stahlkabel to handle heavy steel cables and components with high efficiency, precision, and safety. The entire installation process showcased meticulous engineering and professional execution from start to finish.